17. An impulse of 12.2 kilogram meters per second is delivered to an object whose initial momentum is 4.5 kilogram meters per second. The impulse has the same direction as the initial momentum. What is the object's final momentum? Okay. Now we can write the impulse momentum theorem any number of ways. But however we write it, it says one thing. It says that the impulse is equal to the change in momentum. However we want to write that. Impulse is equal to change in momentum. So impulse is Ft is equal to the change in momentum. You can write it like this. You can write it like we did on the last several problems. Ft is equal to m delta v. M delta v is the change in momentum, so it says the same thing. Now here they're not asking for speeds or anything like that. They're just asking for what the final momentum is. So we can, it's more convenient to use this version of it. Ft is equal to the final momentum minus the initial momentum. So they give us the impulse, they give us the initial momentum, and then we just solve for the final momentum. So the impulse is 12.2 kilogram meters per second. And that is the unit we can use for impulse, same as momentum. Sometimes you see impulse, the unit for impulse written as Newton seconds, which is fine too. Force times time, newtons times seconds. But that's really the same thing as kilogram meters per second, because a newton is really a kilogram meter per second squared. If that's getting multiplied by seconds, that cancels. And what are we left with? Kilogram meters per second. Anyways, P final minus P initial, which was 4.5 kilogram meters per second. So take the 4.5 over to the other side, 12.2 plus 4.5. That gives us a final answer of 16.7 kilograms meters per second for our final momentum.